All right, welcome back to this one. This question says, find 1 plus I in bracket raised to power 20 using De Moivre's theory. All right, this question is under De Moivre's theory. First, what is De Moivre's theory? De Moivre's theory is nothing but a theory in complex number that is used in expanding complex numbers. All right. Okay, so now, first of all, what we're going to do is that this is a complex number. Let's just say, okay, solution. This complex number z is equal to 1 plus I. All right, complex number z is equal to 1 plus I. Very, very important. So now we're going to evaluate this complex number now. I just thought to bring out that which is inside the bracket. Let us take a look at it and evaluate it. Let us find the modulus of this complex number 1 plus I. So z, yeah, okay. I say z magnitude, which is same thing as r. Remember, I told that modulus of a complex number is the magnitude of a complex number, right? So z magnitude is equal to r, which is equal to square root of 1 squared plus 1 squared, which is equal to 1 plus 1 is nothing but 2. And so 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, and so root 2. So the modulus of this complex number is nothing but root 2. Now, let us get the argument of this complex number. So the argument of this complex number, by drawing the Argand diagram, we find that we have something like this, and this is positive, so we place it here, positive 1, and this is 1i, so which is also positive, so we place it here. So the diagonal is here. So taking the argument from the positive x-axis anticlockwise to the diagonal, we have that theta is this. Therefore, and closing here, you have that this is also 1. So using tan inverse now, so theta is going to be tan inverse of 1 over 1, 1 over 1, which is more like saying tan inverse of 1, which is nothing but 45 degrees. All right, so we have something like that. Okay, so now we've gotten this. Now we can now put this complex number. Since we have gotten the modulus of this complex number and we have gotten the argument of this complex number, we can now put this complex number in polar form. So putting this complex number 1 plus I in polar form, it will mean that z is equal to root 2 into cos 45 degree plus I sine 45 degrees. So this is the polar form of this complex number. Now, but because it says raised to power 20, we are now going to apply De Moivre's theory. Therefore, from here now, we can now say that this is actually root 2 into cos 45 degrees plus I sine 45 degrees, all raised to power 20. All right, because this thing inside here is actually equal to this. Now, all raised to power, that's initial 20. Now, by De Moivre's theory, now we've succeeded in putting this complex number in here in the form of in polar form. We can now apply De Moivre's theory. Now, what De Moivre's theory says actually is that we're going to use that integer and raise it to this particular one, and then use that integer and multiply this and this angle here. So applying De Moivre's theory from here is going to be root 2 all raised to power 20 now into cos 45 times 20 plus I sine 45 times 20. All right, so this is what we have. Now, if you now attempt to evaluate this, of course, if you evaluate the whole of this, square root of 2 into 2 times 10. Yeah, into now cos 45 times 20 should give us 900. So we have cos 900 plus sine, all right, plus I sine 900. Okay, now at this part now, this square root can cancel this square, so that I'm going to have 2 raised to power 10 into cos 900 plus I sine 900 close. Now, but 2 raised to power 10 is nothing but 1024. 1024 into cos 900 plus I sine 900. All right, so at this part, we are almost done. So let me wipe off here. So at this point now, we're going to evaluate. If we evaluate cos 900, we're going to have minus 1. And if we evaluate sine 900, we're going to have 0. Therefore, this is 124 into minus 1 plus 0i. Now, expanding the bracket, you're going to have that this is nothing but minus 1024 plus 0i. And this is it. So this which you see here is equal to this in the form of a plus bi. And that's it for this particular question. So do well to like, subscribe, and comment on this channel, and see you in the next part of this video. Thank you.